Hi guys. Uh, so in this video we are going to go this specific lab session, creating a data warehouse through joins and unions. So this is a part of a series which I am currently doing. I have already uploaded this lab one, which is creating querying public tables and load sample data into BigQuery using command line interface BQ. So you can go through that video. I will provide that in the description. So today we will just go through this creating a data warehouse through joins and unions. So this is just a lab, and this will be useful for people who are want to explore Google Cloud services like BigQuery, and also who wanted to prepare for data engineering certification. So I will just start this lab. Let's see how it goes. So okay, this is creating a data warehouse through joins and unions. Okay, overview. BigQuery is Google's fully managed, no ops, low cost analytics database. With BigQuery, you can query terabytes and terabytes of data without having any infrastructure to manage or needing a database administrator. BigQuery uses SQL and can take advantage of pay as you go model. BigQuery allows you to focus on analyzing data to find meaningful insights. The dataset you will use is an e-commerce dataset that has millions of Google Analytics records from the Google Merchandise store. You will explore the available fields and row for insights. This lab focuses on how to create new reporting tables using SQL joins and unions. What you will do in this lab, you will learn how to perform this task, explore new e-commerce data on sentiment analysis, join together data sets and create new tables, append historical data with unions and table wildcards. Okay, so I think I have already gone through the setup and requirements previously as well. So it just says like as we have clicked on this start lab, so that exactly what they are referring to in the setting up this thing. And okay, we'll just go through this thing. Yeah, so I will just open this Google console in, so it will automatically fill in the username. Oh, sorry, yep. I'll just copy this password. Okay, I'll just paste it and next click on then understand. Then now it will automatically open up Google Cloud Console. I have to just click on this agree and continue. Okay, so the BigQuery console, open the BigQuery console. In the Google Cloud Console, select navigation menu, BigQuery, the welcome. Okay, we'll do this, guys. So we'll just click on this BigQuery. So let me close this. So in the search bar, just click on BigQuery. Okay. Click done. Oh yeah. So now this is our BigQuery console. Let's see what task we have to do. So this is our task. Create a new dataset to store your tables. Okay. First, create a new dataset titled e-commerce in BigQuery. So in the left panel, click on the name of the project, BigQuery project. Okay. Click on the three dots next to project. Okay, we'll do that. Create dialogs. Okay. Let's copy this dataset ID name. As we can see in the left, this is our project ID. So click on this. Click the create dataset. Yep, I have. So do I have to click on any data location? Let me just check that. Verify. No. Yeah, and all other options set their default values. Okay, cool. Then I will just click on this create dataset. Let me verify this. Yes, we have created the dataset e-commerce. Cool. Click create dataset. Yeah, that we have done. Let's check our progress. Superb. This is done, and click on a disable editor tabs link to enable the query editor. Okay, I don't see anything to close it. Okay. Scenario: your marketing team provided you and your data science team all of the product reviews for your e-commerce website. You partner with them to create a data warehouse in BigQuery, which joins together data from three sources. Okay: website e-commerce data, product inventory, stock levels and lead times, product review sentiment analysis. In this lab, you examine a new data set based on product reviews. Okay, let me just go through this, guys. I think I haven't understood this correctly. Okay, wait. Your marketing team provided you and your data science. Okay, you partner with them to create a data warehouse and because it joins together. Okay, basically I have three sources of data and I have to combine them using joins and unions, and then I have to examine that, I guess so. Let me just go through this step by step. So BigQuery project. The project your the project with your marketing team's data set is data to insights. BigQuery public datasets are not displayed by default in BigQuery. The queries in this lab will use the data to insights dataset even though you cannot see it. Okay. So data to insights is a public dataset, guys. So as we can see here, we cannot see like the dataset which is right now. We can see only our the datasets which we have created under our project. So they are saying that data to insights is a public dataset. Okay. Explore the product sentiment dataset. Your data science team has run all of your product reviews through API and provided you with the average sentiment score and magnitude for each of your products. First, create a copy, the table that the data science team made, so you can read it. Okay. To create a copy. Okay. Let's copy this query and I will paste this query here. Okay. So this query looks good. Let's click on run. Okay, as we can see here. Okay, oh, this is just creating a table, e-commerce dot products. Okay, so this is a product table which we have created using this query, guys. So from the data to insights e-commerce dot products. So from this public data set, I guess some public data set we have and we have created a copy of this product table. Let me just click on this. Yeah, as you can see, it has created a copy. If you click on preview, you can see the data. It has, yeah, this is schema, details and preview. Okay, so this is only for you to review. The queries in this lab will be using data to insights project. Okay. Oh, okay. Basically, if you go to, I mean, if you check this thing from statement, so data to insights is a project that is similar to this quick labs GCP project, and e-commerce is a data set in this specific project, and product is a table in this specific data set. So that, I mean, we are just creating a copy of this product table in our e-commerce thing. Yeah, cool. Got this thing. So click on e-commerce dataset to display the product table. Yeah, I've just shown you guys that. Yep. So now what we have to do, examine the data. Okay. Navigate to e-commerce product dataset. Okay, and click on preview tab to see the data. Okay. Products. Okay, preview. Uh, we have done. Okay. So how many aluminum handy emergency flashlight have been ordered? Okay, how do we find this aluminum handy emergency flashlight have been ordered? Okay, let me see. This is the ordered quantity, guys, and this is the naming thing. So how do I check? Okay, let me just using command and F. I'll just find. I will try to do alum. Wait, I forgot the name. Yeah, UMI. Okay, I cannot find in this specific page, but I have to go through each and everything. Okay, let me just see. Aluminum, no. I'm just looking at here, this specific field, whether I'm able to find it aluminum or not. No, I cannot find it actually. How many aluminum? Zero? Is this zero? Wait. Handy emergency flashlight. Okay. Let me just check flashlight. Flashlight. Okay. I cannot see that as well. Am I looking at the wrong name, or does this name? Okay, is this a flashlight? It has to, right? Zero, right? This is a plastic sliding. Okay. Power bank explorer. This is a flashlight. Okay. So where is the other one? Shit. Sorry, I cannot find it. Nine? Is it a nine? No. Okay, flashlight nine. Sorry, only nine. Okay. So I think I have to click on this aluminum. Okay, 66. Okay, sorry. Yep, I found it. Yep. So click the schema tab. Okay, what data type are the sentiment score and sentiment magnitude fields? Okay, schema. Okay, sentiment score and sentiment mag. So this is the field. The value is float. Okay, click on that. Yep. So now create a query that shows the top 5 products with most positive sentiment. Okay. SQL. Let me click on this. Compose new query. I'm just pasting this. Okay, this query looks good. We will click on this run. Okay. Now what did we get? So this is the name. This is a sentiment score. I really don't know what exactly does it represent. Okay, this is sentiment magnitude. So what exactly are they asking? What product has the highest sentiment? I can see this product has the highest sentiment score. USB wide soundbar. Okay, in store only. Yep, this is done. Revise your query to show the top 5 products with the most negative sentiment. Filter out the null values. Most negative. Okay, let's copy this thing and try to. I'll just compose a new query. I'll paste this thing. This query looks good. Okay, let's click on run. Let's see the result. Okay, this highest negative, so 0.06. So 7 in so dog frisbee. Okay, 7. So, yep, this is the one. Okay, so let's check our progress. Yep, this is we have explored the product sentiment dataset. Yep, that is done. Now what we have to do, join datasets to find insights. Okay, scenario. Okay, it's the first month of the month. It's the first of the month, and your inventory team has informed you that the ordered quantity field in the product inventory dataset is out of date. Okay, they need your help to query the total sales by product for August 1st 2017, and the reference that against the current stock levels in inventory to see which products need to be resupplied first. Calculate daily sales volume by product SKU. I mean stock. I'm not sure about this full form. So create a new table in your e-commerce dataset with the below requirements. Title it as okay. Source the data from this specific okay value. Include only distinct results. Return product SKU and return the total order quantity ordered product quality quantity, and use sum with a if null condition. Filter for only sales on okay, order by okay, possible solution okay. So I think this is what they have described. They just want us to create a new table under e-commerce dataset with the requirement. So this is I guess this is the query. Let's do it. So okay, I will just close this. Click on this and I will just okay. This query looks good. Okay, let's run it. Okay, I think this is done. Yep. So we have created this sales by SKU. Okay, and it has the data. Okay, let's just see this query. Let me just see what are we doing exactly. Create or replace table. Okay, e-commerce. Okay, this is the table name. Okay, as select distinct product SKU, some ordered. So from this specific table, all underscore sessions underscore raw, we are just filtering out the data using this specific key date keyword, and we are grouping them by product SKU, and the product SKU okay, ordered by total orders. Okay, got it. So now this okay, now click on sales by SKU table. Okay, we have clicked on this thing. Let's go into detail. I guess it is asking for yep. Click the preview tab. How many distinct product SKUs were sold? The answer is 462. Yep. Okay, now true or false? Some okay, this is the top selling product SKU. Oh, let me just see. Preview. Okay, 2899. This is the top product. Yeah, yes, this is true. Yep. Now, next, enrich your sales data with product inventory information by joining the two data sets. So, join sales data and inventory data. Okay. So, we have to join these two data. Okay. So, using a join, enrich the website e-commerce data with the following fields from the product inventory dataset: name, stock level, restocking lead time, sentiment score, sentiment magnitude. Complete the partially written query. Okay, let's just see like this partial query, and if you are not able, if I am not able to come up with that, just I will just look at the solution. Okay. Okay, this is a partial query, right? So left join must have an immediate following on or using okay from this specific table as a website. Left join as inventory on, so on condition okay, select distinct website dot okay, website dot order inventory name from this let me just check this. Using a join, enrich the website e-commerce data with the following fields from the product inventory dataset. So join against product inventory to get name, product inventory. Okay. So what are we missing here? On, so basically I have to mention some on condition. How are we joining these two tables? Website and inventory. Website dot some product. I guess some product. I'm not sure about this, so I'm just checking this. John on website dot product. Okay. product SKU and inventory.sku. Okay, so this part which we are missing. Let me, yep, write this here, sorry. Wait, what's happening? Wait, no, let me just copy this and see. Yep, let's run it. Okay, got it. Yep. So modify the query you wrote to now include the following. Okay, a calculated field of total underscore ordered divided by stock level and alias it ratio. Okay, hint, use safe underscore divide field 1 comma field 2 to avoid divide by 0. Okay, it will just check the values to 0. Okay, when the stock level is 0. Filter the results to only include products that have gone through 50% or more of their inventory in already at the beginning of the month. Okay, let's copy this thing and I will create a compose a new query. Let's see what does it doing. It is selecting values from website table and from the inventory table, and using a safe underscore divide, it is taking totals ordered and the inventory stock level as a ratio. This is one other field from e-commerce dot sales. Okay, left join like inventory. Okay, cool. Okay, let's just run. Wait, yep, it's good. Yep, this we have done. Now what do we have to do? So what is the name, what is the name of the top selling product and what percent of its inventory has been sold already? Okay, let's see the results of this thing. Total order 250. I think this is leather general back, stock level is 354. So how do we say it is top selling product? Okay, by total underscore ordered, I mean, okay, leather general black, stock level is 354. So 154, I mean 104 is still, yeah, leather bag with 250 product orders out of, yep, this is the one. Yeah, now just check the progress. Yep, this has been done. Superb. Now what do we have to do? Append additional records. Your international team has already made in-store sales on August 2nd 2017, which you want to record in your daily sales tables. So create a new empty table to store sales by product SKU for, okay. For the schema, specify the following fields. Table name is this, okay. Product, so this is a schema, table name, this is a field name, okay, possible. Okay, I'll just compose a new query. Create or replace which table it is affecting, sales by SKU. Okay, it is creating, yep, it is creating a new table. Okay, interesting. Yep. So confirm you now have two date shared sales table. Yep, sales shared. So date shared sales, yep, we do have two. Use the drop down menu next to the sales by SKU tables or refresh your bar to see listed in the left menu. Okay, yeah, we have seen. Now insert the sales record provided to you by sales team. Okay, compose a new query. Values, okay, run it. Yep. This is done. Click on this, preview. No table, I mean no values. I think we have inserted into this. Let us check. Confirm the record appears by previewing the table. Click on the table name to see the results. Okay, let me just refresh this thing. Okay, I'm just checking. Okay. Oh, yeah, it has been done. Now, append together historical data. So there are multiple ways to append together data that has the same schema. Two common ways are using unions and table wildcards. Union is a SQL operator that appends together rows from different result sets. Table wildcards enable you to query multiple tables using concise SQL statements. Wildcard tables are available only in standard SQL. Write a union query that will result in all records from the below two tables. Okay. So union all, okay. We are basically appending together the values, historical values. I've copied this query. Let me just compose a new one. Okay, we have union. Okay, this is the data which we have got. So, note the difference between union and union all is that union will not include duplicate records. What is a pitfall of having many daily sales table? You will have to write many union statements chained together. A better solution is to use the table wildcard filter and the table underscore suffix filter. Write a query that uses asterisk table wildcard to select all the records from e-commerce for the year. Okay. Possible solution. Okay, whatever. Okay, I mean, it will just this asterisk. It's like an regex operator. Like it will just get all the tables which are ending with I mean 2017 and all the rest of other characters. Modify the previous query to add a filter to limit the results to. Okay, let me just see check this query as well. So it will do the same operation, but okay, let's just check. Superb. So instead of using union all, we can just mention this asterisk symbol, which will just take in all the table names which are starting with this and ending with any other values. Good. So modify the previous query to add a filter to limit the results to, okay, a table underscore suffix. So good, interesting. So this would be the same, but if you want to limit to only specific, I mean this asterisk represents 0802. Okay, now just click on this. So now I think we will get only one. Yeah, interesting. A union all. Okay, this is done. And note another option to consider is to create a partition table which automatically can ingest daily sales data into the correct partition. Okay, I haven't done that. I will just go through that if in the future. If okay, a union all join does not include duplicate records. False. Let's check this our progress. Superb. I think we have completed everything. Let's check this thing. Happened. Oh yeah, I think we have. Yeah, reached it. So yep, we got a score 100 or 100. Okay, I think we have pretty much completed within 30 minutes, guys. Okay, superb. Sorry if I am going very fast. We are on a time, so I thought would take more time. So yeah, but took a little time. So I'll just give you a brief on what we have done on today's lab session. So today, I mean, basically we have created a data warehouse. In the sense, we have just gathered data from different sources and we have analyzed the data using joins and unions. So this is an overview which we have gone through, and we have gone through this BigQuery console. Okay, we have created a data set, and oh, I think you can also see what we have done in the right hand section of this lab. So we have created a new data set to store our tables. Then okay, I will better it would be I will just go through this details. Yeah, not highlight part. Okay, we have created a new data set to store tables. Okay, then project. So this is a public project which we have I mean uh, I mean we have sourced the data from this specific public project. We have then explored the product sentiment dataset. Then this is we have examined the data, analyzed the data. Then we have just created some queries, and we got we have analyzed the data as well using queries. And then we have joined data sets on a specific condition. I mean, basically we have created a tables. Superb. Then we have joined sales data and inventory data using left join on the condition with this thing. Yep. Then we have modified the query. We have added a new field like total order by stock value as a ratio. Then we have analyzed the data. We have gone through that, and we have answered these questions. We have appended additional records uh, by creating a new table. I mean, we created a new, basically we created a new schema. That's a new table. Okay. Then we have appended with historical data by using union all. So now instead of using union all, we can use asterisk and table wildcards like table suffix filter. Okay, that we have gone through as well. We have we have we have answered this thing. Okay. Yep. Thanks, guys. We have pretty much done it in 30 minutes. That's really good. So I'm just ending this lab now. Let's see. Let's give 5 stars. Okay. Now let's just see the progress. Super. We have completed these 2 labs out of how many? Let me just check. 1, 2, 3, 4, 5, 6, 7. So we have completed 2 labs out of 7. I will try to complete these remaining labs as well, guys, and I will upload the videos. Yep. Thanks for watching.